So in this video we're going to look at quadratic functions, and we're going to be analysing them very carefully by graphing those functions onto x and y axes. So let's use fairly difficult problems to deal with in this video, and then if things are easier, if the problems that you're given are easier, then well, hopefully you'll be more confident. But I'm going to start with something which already has a coefficient of x squared. So if we have something like y equals 4x squared plus 3x minus 1. Okay, because I know this one works out fairly neatly, but still, it's a fairly difficult challenge, but it's one that's going to give us some really interesting things to work with. So the next stage is to draw the axes then, and you'll begin to see how I'm going to operate in this video. So if I now label my axes very carefully, because how we label our axis determines how we're going to zoom into this and see what's going on. So if I put my 0 there, let's put x and y in straight away. What I'm going to do, in fact, is zoom right in, because I can see that these values here are going to produce not only small integers but also fractions, and I want you to see very clearly what's going on. So I'm going to put my mark there, so there's 5 squares along. I'm going to just make 1, so 1.0 if you like, and so 5 squares in this direction minus 1, and I'll keep it proportional. You don't have to do that, but I'm going to keep it so that the x and y values are the same distance apart. So we've got positive 1 on the y value, on the y-axis there, and minus 1 there. Okay, so now I've set up my axes. I'm ready to plot my function. Now, a good place to start is if we know the shape roughly of a quadratic function, in other words a parabola. So the curve of a quadratic function is this parabolic shape which comes down like this, intersects with the x-axis usually, unless it's above the x-axis or below it, but usually intersects with the x-axis, then it's going to cut across the y-axis at some point, because one value only of x is going to equal that y value, and then it's going to have a turning point. It will turn around here, and then it will go up, and it will intersect with the x-axis again, because usually there are two solutions to a quadratic equation, okay, when we solve for x, and that's why, because it intersects twice. So that's what we're looking to do. We're looking to plot something like this, kind of U shape. And I know it's a U shape rather than an N shape, because it will pop in the other direction, only when there's a negative coefficient of x squared. So we are looking for something that opens upwards. Okay? Okay, let's go ahead and plot. Well, first of all, what I'm going to do is look at this y-intercept. So where it intercepts with the y-axis, I know that x is going to equal 0. Well, if x equals 0, when x equals 0, then this function becomes very, very straightforward. Y must equal 4 times x squared. If x is 0, is just 0, so 4 times 0 is 0. So it cancels that. Nothing going on there. It's going to cancel this as well, because 3 times x is 0, so 3 times 0 is 0. So all we get is, when x equals 0, all we get is this constant at the end of the expression, so y equals minus 1. So it's the easiest thing to do to plot the y-intercept, and so I like to do it first. Okay, so when x equals 0, y equals minus 1, it's going to pass through this point here. Okay, now what we'll do, and I suppose the next in level of difficulty, we're going to go for the x-intercept. So where is it going to cross the x-axis? Well, it's going to cross the x-axis when y equals 0. In other words, if we substitute 0 into this equation, y equals 4x squared plus 3x minus 1, if we substitute y into there, we end up with 4x squared plus 3x minus 1 equals 0. So 4x squared plus 3x minus y equals minus 1, sorry, equals 0. Now to solve this quadratic equation, let's go for factoring. Now of course you could do it quite easily by other methods, certainly by the quadratic formula and by completing the square. But just because I want to practice factoring, let's do it by this method. So the first thing we do with factoring is we identify the product and sum. And in this case, the sum is 3. And the product is going to be 4 times minus 1, so that's minus 4. Okay? So now, immediately we're going to get minus 1 times 4 as our product pairs, and we can see that that's also going to sum to 3. So very quickly, it's worth though just making a little grid so that we can see how this works using grid method. So when we're factoring or factorizing, what we're actually doing is splitting that middle term, and the grid shows that very nicely. So we've got a 4x squared term, and we've got a minus 1 here, but that 3x has to split, and we now know that it splits into a minus x, which we can put here, plus 4x. Okay, and that means our factors must be 4x here, times x gives us our 4x squared, x times minus 1 will give us our minus x in that quadrant there. In this quadrant here we get plus 1, because 1 times 4x gives us our positive 4x. And in the final box here we get 1 times minus 1, so minus 1. So that's factored, slightly long-winded way, but I've done it in that way just to show you what we've learned previously and applying it to this problem. So now we can factorize this, and we've got 4x minus 1 times x plus 1 equals 0. And if that's the case, therefore, using the 0 product property, we know that either 4x minus 1 equals 0, in which case x must equal 1/4, or and in this case we'll say and, x plus 1 equals 0, in which case x must equal minus 1. So there we go. There we've got our x-intercepts, so that we, whoops, there we go. So we can tell now that x is going to be intercepted by this curve at x equals minus 1, so we can draw that in. And then we've got positive quarter. So if using this numbering that's a half, then a quarter is going to be exactly here. Okay, and I'll just erase that little working mark there. So very good. Let's review what we've done so far. We've worked out that this curve is going to intercept the x-axis first here as it comes down, then the y-axis here, then at some point it's going to turn round and it's going to travel back up, exactly symmetrical with the right hand side, and it's going to intercept the x-axis again at this point, x equals minus 1. So the most difficult challenge here is to find this turning point, but actually it turns out that that's not very difficult at all, and I'll show you why. Now there are a couple of ways of doing this. One is to rearrange that into completing the square form, or sometimes known as the vertex form, but I'm going to use a much simpler method. I'm going to use the quadratic formula, because we know that the quadratic formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. We know that this bit will equal 0 at the turning point. So this is called the discriminant, and the discriminant only has well, the discriminant equals 0, so b squared minus 4ac has got to equal 0, like this. Erase. There we go. It's got to equal 0 at the turning point, because if you think about it, that will only give us one solution. Okay, 0 is the only number that only has one square root. In other words, 0. All other numbers will give you 2, this positive and negative. But 0 is the only number that will give you just one value. Okay, and at the turning point, there is only going to be one value for x, because it's literally because it's turned that corner, and both these values here, both these x points, they're going to come closer and closer together until they just join at the turning point. So in that case, if we've got minus b plus or minus the square root of 0, then we can just eliminate that 0, because the square root of 0 is 0, and so we certainly don't need the plus or minus. Okay, so I'm just going to erase this. We end up with a handy formula. Some people just learn it and memorize it, but they don't know where it comes from. In this case, though, well, you need to know really that it comes simply from the quadratic formula. So you don't need to memorize something new. You just need to think of the quadratic formula, eliminate the discriminant, and you just get minus b divided by 2a. Okay, good. So now, to find the turning point, all we need to do is plug in our values. And we've got them nicely laid out up here. We know that b is 3, so x, so let's write at, we don't need to write turning point, we'll just put tp, at tp, x equals minus b all over 2a. Therefore x equals minus, there we go, minus 3, and 2a, well that's 2 times 4, that's 8, so x equals minus 3 divided by 8, or minus 3/8. So I thought we were going to get into fractions, but we've got a nice numbering on our axes, so everything should be fine. Whoops, I want a different colour here. Okay, so now what do we know about this then? We know that it's going to turn somewhere down here, and we also know that it's going to be exactly symmetrical. So what we should have is our minus 3/8 value, in other words x equals minus 3/8, should be, well, if here is, let's say, if this is 1, so we've got minus 4/8 would be a half of that exactly here, in other words. So that would be minus 4/8. A quarter would be minus 2/8, so that would be exactly here. So it's going to be just to the right of that line there, isn't it? So it's going to be exactly here. Now, our double check is it should be exactly in between these two x-intercepts here, because it's a symmetrical curve. A parabola is going to be a symmetrical curve. There's no angle at all. So what we can do then is, again, just check it is halfway between those two. We can draw now an axis of symmetry, like this. So if I draw a line down here, let's just draw an arrow to indicate that that goes straight up here, but if I draw a line down here, hugging fairly closely that line on my squared paper there, I know that somewhere on this line, intercepting this line in fact you could say, is going to be my turning point. So there's my axis of symmetry. You don't have to draw that, but I think it's rather nice, and it will help with drawing the graph a little later on. Okay, so what is going to be my y value? We know what the x value is now. What's going to be the y? Well, to get that, all I need to do is substitute my x value into the original equation. So if x equals minus 3/8, then y must equal 4 times x squared. So we've got minus 3/8 squared plus 3 times my x value, minus 3/8 minus 1. And that looks a little complicated, but it shouldn't give us too much trouble. All we need to be fairly good at is basic arithmetic. So 4 times minus, now that's minus 3/8 needs to square to start with, so we're going to go 4 times, well, minus 3 times minus 3 is 9, and 8 times 8 is 64. Okay, plus 3 times minus 3, whoops, let's just erase that. So 3 times minus 3 is actually going to give us minus 9, minus 9 eighths, and since we seem to be working in eighths, I'm going to say minus, not minus 1, but minus 8/8, which in fact is going to make life a lot easier, isn't it? It's going to be minus 1/8. Why don't we do that now? So let's just erase that and put minus 1/8. Okay. So all we've got to do now is multiply out this bracket here, and we get, well, in fact, before I do that, why don't I just cancel? So 4 into 4 goes 1, and 4 into 64 goes 16. Now that's made life a lot easier. So now I've got 9 minus 2 all over 16 gives me 7/16. 7/16. Okay, now I was expecting a negative here, so I think something's gone wrong, and that's fine because mistakes happen all the time, and I guess it probably happened here. So I'm just going to go back and redo this. Very often, instead of trying to work through your mistake, it's a good idea just to have another go. It's a lot quicker that way. So what have I got here? I should have, I can see where I went wrong. Minus 9/8 minus 8/8 is actually going to give me minus 17/8. So I was too quick to cancel that, and it's a good job that I knew that I had a negative, because that gave me the clue that I went wrong. So instead of doing that, let's just write it out in full. Always a good idea not to make shortcuts. So I've got 9/16 minus, what have I got? 17/8. That's going to give me, can I squash it in here? Why not? Okay, 9/16 minus 34/16, like that. And okay, I think what I'll do, I don't want to interfere, well, why not, let's just squash it in, it's just enough room. So 9, well, I could say, well, let's think of 9 minus 34 as being, it's going to be 25, isn't it? There are various ways that you could simplify that, but in the interest of time, let's just write it straight down. So minus 25/16. And I will just jot down here that minus 25/16 is going to be 1 and 9, sorry, minus 1, let's be careful, minus 1 and 9/16. Because if I put it in mixed numbers, it's going to be easier for me to plot on the axes. So there we go. Make that a bit clearer. Minus 1 and 9/16. Okay, so now I've got my y value and my x value. I've got minus 3/8, and I've drawn already the axis for that. And now I'm going to have minus 1 and 9/16. So I can use my yellow pen here again. Well, minus 1 is here. Minus 2 would be slightly off here. So minus 1.5 is going to be here, and it's slightly more than that. It's about minus 1.56, I would say. So it's going to be here. So y equals minus 1 and 9/16 or minus 25/16. It's going to be here. I'll just do arrows. So my turning point is going to be where these two intersect, which is going to be exactly there. And that completes our work on this equation, because what we've got is all the information we need now to draw the curve. I'm going to use a different colour pen, and usually of course you'd use a pencil. Let's just use this colour here. What we can do now is draw a few lines in that we're going to join up. What we don't want to do, by the way, is something like that. Try and draw it that way. That is just wrong, because you've got gaps, you've not got your line joining up, and this is a continuous line, so we need to be careful about that. You can lose marks if you try and plot a graph in that way. So instead what we do is, if we draw a line where we're going to go through here, okay, so it's going to be something like that, not a broken line but a continuous line here. And if we draw a line exactly symmetrical to that, so going in the same sort of direction, so draw that, whoops, let's have another go. Okay, that looks about right. There we go. I think what I'll do is I'll move that because we don't need it anymore. And have a look at what I've got. Yeah, that's looking about right. Okay. Okay, so it does take a little bit of effort to draw these things, but it's worth doing, and you do really need to do it carefully, quite carefully. So there we go, something like that. Now at this point, the turning point, we do not have a point. We actually have a level line here, but it's going to curve up straight away. So I'm carefully going to draw a turning point like this. Okay. Now at this point, we can see it's going to go through like this. So again, taking quite a bit of care, making sure it's curving up towards that point there. And in fact, what we can do is we can say, well, over here, so it's going to be there, isn't it? So plotting exactly that distance from there to there, this is where we're going to get the other part of our line curving like that. Right, maybe that's a little bit too much of an angle, so I'll just adjust it like that. Okay, so now you can really see that parabola forming. I could extend these points here, but I really don't need to draw this top part here, so I'm just going to draw in some arrows there. I could draw some dots here. Dots are quite handy to be able to draw everything nice and accurately, so get everything lined up. Of course, again, we ought to be looking at our symmetry here, and now I can just join the dots. Okay, so there we go. So there's one part. It's getting a bit wobbly here, this pen is quite tricky to handle, but there we go. And down here, I must make sure I do join this bit here. And then finally, because if I didn't, I would be suggesting it wasn't a continuous function, which it is. Well, there we go. I could continue sort of neatening this up, which is quite a nice little activity to do, but it's going to make the video far too long. So I think you can see, there we go. We've got a pretty neat enough anyway, parabola. Okay, and now, sadly, I'm going to erase my artwork and try a different problem. So, there we go. Now this time what I'm going to do is I'm going to use some slightly larger numbers, but also keep it, let's write this g of x. Okay, let's just erase that. Give ourselves plenty of room. So g of x equals y. Now the reason why I'm calling it g of x is because I might want to draw it on the same graph. I haven't decided yet. I'm just selecting from a little list of things I know work quite well here, what it is I'm going to use. And I'm going to use this one, 3x squared plus 17x, because I know that's going to give us some interesting numbers. But really anything will work. And what I'm going to do, I think I'm going to change these axes straight away. So I was zoomed in last time, but because the numbers are quite big, I'm going to zoom out now, and I'm going to redraw this up here. So my x-axis is out of the way, because we know that we don't really need to think about what's going on above the x-axis when we're looking at the problems, this sort of problem in this way. I'm not quite sure how to number my axes, but I think what I'll do is just go 2, 4, 6 and see how that works out. Okay, it's very important to think about numbering your axes. Oops. Because otherwise you're not going to be able to draw things very accurately or see what's going on. Okay, and then my y-axis I'm going to keep proportional. So if I put minus 5 here and minus 10, and is that 5? Yeah, minus 15. Okay, I'll put my 0 in there, label that y, label this x, and now I'm set up ready to plot my parabola. Okay, so the first thing we do is we say, well, when x equals 0, y has got to equal minus 6. So I could immediately plot that on the graph at minus 6. So x equals 0, y equals minus 6. So there's my first intercept, my y-intercept. The curve's got to go through there. Okay, now I'm going to solve the quadratic equation. And having a look at it, actually this isn't going to take very long at all, because when y equals 0, let's write it down, 3x squared plus 17x minus 6 equals 0. I can immediately see how that's going to factorize, because 3 times negative 6, let's make that a bit clearer, is going to give me minus 18. So sometimes you don't need to use the quadratic form. You can just use trial and error. You can just see what's going to happen. If I'm going to have 3x in that bracket, the x here, and I write minus 1 there, and plus 18 here, sorry, plus 18, plus 6. Let's just make that bracket a bit smaller. Okay, plus 6 here equal to 0. You can see how this is going to work out. So using just a simple, I was just looking at it, I could see that trial and error, I suppose, 3x times 6 is going to give me my 18x, and then minus x gives me my 17. So I didn't need to do any working out. I could have done, and nothing wrong with doing that, but if you can jump that stage, the nice thing about factorizing is that you can just check at the end. So I know that's definitely correct. All right. Good, that saved a little bit of time. Now we can just go ahead and say x must equal then, change the sign, 1/3, and x equals minus 6 when y equals 0. So that's my x-intercepts done. Let's plot them then on the graph. So I've got minus 6 over here, and a positive third. Well, that's 1, so a third must be here. Okay, so we can see what's going to happen now to our graph. It's our parabola is going to come down here, pass through here. It looks like it's going to go really deep because it's at such a steep angle. At some point it's going to turn here. I can even draw on straight away my axis of symmetry because it's going to be exactly here. So if I just use there we go. That there should be my axis of symmetry. But I'm going to work it out using my turning point as well as a double check. So I need to find that point there. that x value. All right. So what we say is that when, or at the turning point, at the TP, like this, x has got to equal minus b, remember? So part of the quadratic formula without the discriminant. And in that case, x must equal, so therefore x has to equal minus 17 over 2 times 3 over 6. So minus 17 sixths. So, is that correct? Well, minus 17 sixths, it's going to be 2 and 5 sixths. So it's negative 2 and 5 sixths. So that's negative 2. That would be negative 3. And that looks exactly right. That's negative 5 sixths. So somewhere on this axis, I'm going to find my y value and my turning point. So let's have a go. So we need to substitute x equals minus 17 over 6, minus 17 sixths, into this formula here, into this quadratic equation, I should say. So let's do it algebraically. So we've got y equals 3 times minus 17 over 6 squared plus 17 times minus 17 over 6. So that's our x's put in, and then finally minus 6. Well, I can see we've got sixths here, so I suppose I might as well go straight for minus 36 sixths, although I think that's going to change again. But there we go, that's all we've got to do. Once we've done that calculation, we'll have a y value, which will give us our turning point, and then we can draw our curve. Okay, so simple calculation. Now, if you know your square values, it really helps. 17 times 17, 17 squared, is 289, and that's going to cancel out that negative. So what we're going to get is 3 times 289 here. Oh, that works out really nicely, because divided by 36, which is 6 squared, means we can cancel straight away our 3 and our 36 and end up with 12. I think I'm just going to erase that so that it doesn't look too messy. But if you were doing this in an exam, you would just... so let's get rid of these parentheses as well. So 289 divided by 12. Okay? 289 divided by 12. So that's sorted out that bit there. Very good. Okay, now 17 times 17 again is 17 squared, so it's going to be minus 289 divided by 6. And in fact, again, what I would do is just double this up to get 12. So I can see I'm going to need 12ths. So what's 2 times 8? 289. Well, that's going to be 578. So I could cancel it. So normally I'd do this and this, but it's going to get so messy, I'm just going to use my eraser and write 578 over 12. Okay, 578 divided by 12. So there we go. That's done that bit, and now I can double this to get 12ths again. So I've got 72 divided by 12. So everything over 12. And so I can tidy this up. In fact, I might as well just treat these. Okay, so if I just group these, then I can sort that out, because 578 twelfths minus 72 twelfths is going to give me, well, if I write this bit here, 289, subtract this bit, which is going to be 506 twelfths, so all over 12. Let's just tidy this up. Okay. And then we've got a simple, well, not too simple, but we've got a subtraction to complete. So I'll use a new line for this so I don't interfere with my graph. So subtracting 500 is going to be a lot easier. So what I want to do is take 6 off this. So I'm going to rewrite this 283 subtract 500 divided by 12. And so I've got negative 200 and what's that going to be? 17 divided by 12. Right. Well, that was, a fairly challenging bit of arithmetic, but it was just arithmetic, and it's, as long as you are fairly fluent in arithmetic, you should be able to get down to this stage. And now we've got another piece of arithmetic, which is a division. So I'm going to divide 12 into minus 217. I'll put my negative sign on at the end. I need to remember to do that. But 12 into 21 just goes 1. So I'm using short division. And that leaves me with 9 here. If I just use a different colour. Again, I just want to keep things very clear for this video. But usually, obviously, we wouldn't be using coloured pens or anything. So 12 into 97. Well, 12 times 8 is 96. So there we go. That gives me my answer. 18 and 1/12. Brilliant. That's my turning point. So if I mark it on my graph, I've got minus 18 and a 12th. That's going to be just a tiny, just shaving off that 18 point there. So that's going to be just there. And now we've got all our points on the graph. We've got our Y-intercept, we've got our two X-intercepts. We can see our graph is going to come down like this. I just need to join up my points. And this may be a little messy because I don't want to spend too much longer doing this. But I'm going to start by doing these points here, drawing an arrow there. I need to make sure this is a pretty steep, there we go, something like that. Pretty steep line here because it pretty much goes down vertically at this stage. Okay, now I'm just going to erase this X here because I don't want to give the impression that, there we go, the line goes through there. Now, to get through to here, through my Y-intercept, I'm going to have to draw a line something like this. It's got a little bit too thick there, but I think it's about right. You can see how that still isn't angled. It needs to be pretty much vertical. What? Now the point at the bottom, remember, it's exactly horizontal here, but it's going to turn pretty quickly. So I want something like this as my turning point. Okay. And now my dots will come down like this. And if I mirror this point here, what have I got? It's going to be about there. Is that about right? That looks about right. So again, a fairly steeply angled line here because it's got to connect up to there. There we go. Something like that. And my dots again, mirroring either side of that axis. And then the rather challenging problem of joining up. Okay, joining up these points. There we go, something like this. Join this bit up here. Okay. It is quite tricky to do with this pen. With a pencil it might be a lot easier. There we go, something like that. It has gone a little bit out of line here, hasn't it? But in the interests of keeping this video reasonable length, I'm not going to spend too long doing this. Okay. Yeah, that really isn't working out very well, is it? I should just erase that. Okay. In fact, I'm going to erase the whole of that. I think those points weren't very well done to start with. Let's just have another go at that. Okay, so there we go. Go down. Let's do my points again. Making them, that's a bit better. Like that. Drawing these up. Remember, no gaps, because this is a continuous variable. Drawing this up here. Drawing this up here. And I don't like that dot there. Yeah, that's not quite right. Okay. So let's put a dot there. There we go. That's a bit better. And I think that will be good enough. I'll stand back and admire my artwork. What do I think? Not bad. That certainly looks like a parabola. It's certainly doing what I want it to do, and it shows basically that I've analysed as carefully as I can all those intercept points and the axis of symmetry for my parabola. So there we are. So finally, let's just have a look at that formula again. X equals minus b all over 2a. I think the only thing we need to say about this is, again, that it derives from the quadratic formula. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. And of course what we were able to do was we were able to erase all of this, because at the turning point the discriminant must equal 0, and that's because it's the only number that produces one solution to the square root. So we can then erase all of these ideas and derive the minus b all over 2a formula. Okay, one final thing to say about this is an interesting idea, really, is that if the discriminant is greater than 0, then we can say, well, we must have two solutions, and often we call these two roots when we're solving for x. Solving for x. Okay, and that's a very normal situation. The other situation that we've just discovered is that right at the tip of the curve we have this situation where x just equals 0, and therefore we only have one solution there, or one root, when we're solving for x. But there's the other idea, and this happens fairly frequently. The other situation that might occur is when we have the discriminant, that area under the square root sign, as being less than 0. So when we've got b squared minus 4ac coming out to a negative number, let's say that was 64, let's say, and it was minus 4 times 6 times let's say 3, would that get us to, yeah, so that would get us to 72, so that's going to be it's going to give us a negative value. Okay, now if that's the case, then we're going to have this situation of the discriminant being less than 0. In other words, underneath the square root sign here, we're going to be trying to square root a negative number. Well, we can't do that usually, so we say there's got no real roots. But we have to say real, because there is a branch of mathematics that talks about imaginary numbers, in which case, you know, there is a solution. But usually when we're talking about the real numbers, where all we're doing is working with the real numbers on both of those axes, then there's no solution to that situation. So if the discriminant is less than 0, no real roots, we can't solve for x. Okay. One